Hi, Feng.
Hi, Han.
How's everything? So you're gonna host the meeting, right?
Yeah,
Okay. So yeah, I asked all my students to be here, so they will, yeah, okay.
yes,
Host the meeting. Yeah, I also streamed this on YouTube.
that's great. So, will the speaker be able to share his screen and present?
I think so,
Okay, great.
right? But I will stand by if anything happened. I will give you the host.
Sure.
Co-host should be fine. Okay.
Hi, James.
Hello.
Hi, how are you?
Great. Good morning.
Morning. Yeah. Thanks
Good to see
again
you.
for for your support and
Oh,
yeah,
yeah. Happy to be here. Yeah, for sure.
yeah.
Very nice.
So yeah, so we will wait to 11 a.m.
Oh,
Uh
yeah. No, I joined early. I know how these things go.
yeah. And I will first introduce you and then you can share your screen and
Okay.
start your talk. And all,
Great.
yeah, so yeah,
Cool. And this it's an hour, but I mean I'll have time for questions and stuff. So, but we finish hard after an hour. Yeah.
yeah, sure.
Okay. Cool. Awesome. Hey, Hong, how are you? Nice background.
Yeah.
I'm going to use some very reddish Chinese. This is Chinese festival, so
Yeah.
we
Happy New Year. Yeah. Just a couple
Yeah.
days ago. Yeah.
yeah. Um, I was trying to set up the YouTube because there's some guys they're looking for YouTube, so I was setting up.
Oh, okay. Cool.
Yeah. Okay.
And one of our other organizers from UC Davis.
Yeah.
Very early for you.
Hi, James.
Morning. Morning.
Morning.
I have a friend who joined UC Davis computer science. Zhao from he was at Google for many years.
Hello, everyone. Hello, Jim.
Hey, morning.
Morning.
So the NSF grant that supports this, is that a 3-year thing or a 4-year?
4 years.
4 years. That's
Yeah.
great.
Yeah.
That's really great. Oh, I see the YouTube link up top. So it's on YouTube now as well.
Yeah.
Nice. So that's integrated with Zoom? You do it directly through Zoom or you go through YouTube?
You go through Zoom.
Oh, I gotta look into this. That's very cool.
Yeah, very quick.
Yeah,
Single.
yeah, yeah.
Yeah.
Neat.
Yeah, maybe we can start now. Let me first introduce our speaker. So, hello everyone. So my name is Feng Chen, and I am an associate professor in the computer science department at UT Dallas. And so I'd like to extend a warm welcome to all attendees of our inaugural seminar in the series Computing Futures, Challenges in AI, Ethics, and HPC. So it's my privilege to introduce today's speaker, Dr. James Caverlee, a professor in the Department of Computer Science and Engineering at Texas A&M University. So Dr. Caverlee is distinguished for his contributions to connecting people with information through his development of algorithms and systems that are trustworthy, resilient, and responsible. So his work has been supported by an NSF Career Award, an Air Force Young Investigator Award, and a DARPA Young Investigator Award, among many others. He has been honored with the 2022 CIR Test of Time Award honorable mention, and 2020 CIKM Test of Time Award, and numerous teaching awards at the departmental and college levels. In 2020, he served as the general co-chair for WSDM. Without further delay, I invited Dr. Caverlee to share his screen and begin his talk.
Great. Thank you so much for that
Thank
very
you.
nice introduction.
Thank you.
I'm going to try to share my iPad, which I'm hoping this works. Okay. You guys can see
Yes.
that?
Yes.
Okay, cool. Yeah, and I had to add the notation. I didn't realize this is the very first seminar, so I feel lots of pressure to to give a great talk. But thank you all for being here. I really appreciate the opportunity, and I think this is a really cool kind of series you guys are setting up. And I know you have faculty and students from kind of all over the country. So yeah, just want to thank our organizers up front. I really appreciate the invitation and everybody on the Zoom. Particular shout out to everyone on the West Coast. Maybe it's a little early for you, but we're glad you're here with us. Yeah, so this is broadly, this talk title is about ethical AI. And so what I want to do is I'm going to walk you through 3 projects that I've been working on recently. And I think they're kind of diverse projects. So if you find one to be kind of boring, just hang on, maybe you'll find the other ones more interesting. But in our group, we're working on lots of kind of different problems. And so I wanted to give you kind of a sense of the breadth of our work. Sort of as background, right? So I think maybe this is appropriate for this series. And a lot of you know that, AI is basically driving the applications that we use every day. And if it's not doing it today, certainly very soon it will be. So Google search, if you use it now, it has like an AI generated summary up top. We're all engaging with different large language models, but other applications include, how we learn, clinical decision support to help doctors and so on and so forth. And so AI is basically embedded in and only growing more powerful. But historically, like even before like this LLM foundation model world, we knew that relying on AI or machine learning could still have risk and harms. And I just put a few examples here, and I'm sure in your own research or your own just sort of awareness of the news, you've seen many of these examples, right? Bias that arises in job hunting, exposing children to inappropriate content, political polarization, chatbots that mistakenly guide children to do dangerous tasks, and so on and so forth. So kind of as this AI kind of revolution continues, we need to be very careful and think about the risk and the harms. And so in our group, very broadly, we've been thinking for many, many years about responsibility in these AI systems. How do we build responsibility into that? And so the idea here is right, sort of on the left-hand side, that's the AI system. But we're interacting with real people, right? And so we need to be very careful. And I think this is kind of, in the description of this series, there might be some philosophers here. So I wanted to be upfront and say, I'm not a philosopher. And I think most computer scientists are not, at least not good philosophers, okay? We know how to build algorithms and systems. But when you think about responsibility in these AI systems, I think it's kind of a vague term. And we don't have a good handle on how we define it. Do we mean fairness? How do we define fairness? Is it trustworthiness, dependability? How do we measure these concepts? How do we align our research efforts? Plus, you can imagine many, many other thorny issues. And so I just want to kind of put this up front, saying I really enjoy the topic of this series, that we really need close collaboration across disciplines, certainly now more than ever, because the AI is only going to have more impacts, and we need to be very smart and very, very deliberate in how we do development there. So I just want to kind of put this up front. Now, to give you kind of like some insight into, me as an armchair philosopher, my aha moment is, I'm working with different kinds of problems. This is a recommendation problem. So on the y-axis, some goodness metric, and this is like different groups of people. Okay. And what we were looking at is basically, we had a system, and this is sort of the distribution of kind of the goodness, how it was allocated across different groups of people. And the students and I were working on this problem, and we're trying to figure out, like, what's the best outcome, right? Like, if we could improve upon this, you could imagine kind of two worlds. There's a world where, all these numbers are equal, but maybe lower overall. We could have a world where, we really supercharge the top of the distribution, or even, vice versa. But the idea is, like, so what is the distributional impact we want to have? And so we had a big debate about this, because in a lot of context, you may increase the average goodness over all the users, but have different distributional impacts. So you may impact certain groups more than others. And so this is really my aha moment in thinking about, like, gosh, I really don't know the right way to approach this problem. And so again, I'm not a deep moral philosopher, but John Rawls is at least someone I encountered in my like 101 class. And basically, this is sort of the classic Rawlsian veil of ignorance. The idea is you're sort of imagining, we're trying to design a world in which we don't know who we would be in that world, right? And so the idea is you want to sort of design policies that lead us to sort of a more fair world. And so practically, we can kind of encode that as Rawlsian maximum fairness. And so the idea there is, among all those possible alternatives, like how we structure the society or how we structure these systems, we want to pick the alternative that maximizes the minimum utility of all the individuals in society. So if you think about that maximum fairness, right? If you go back to this figure, the idea is we really want to spend lots of attention down here in the lower part of the distribution. In other words, the people on the right-hand side, they're already doing pretty well. But, ideally, wouldn't it be great if we could, increase all of these numbers, and basically provide like a better, a better result. So we call those neglected tails. The point here is, like, a lot of times when we focus on top line metrics, just sort of the average across these 5 groups, we can raise the overall, but not necessarily consider those tails. And so this is really kind of focused a lot of my research in the last few years to really think about the distributional effects and to really focus on maximizing this minimum for our different users. So this is kind of abstract so far. So what I want to do in the rest of the talk is focus on 3 different topics where I hope you'll get a sense of these neglected tails and this idea of how we can build systems and we can think about our analysis in terms of these neglected tails, okay? And so I'm going to talk about this first project is going to be more of a kind of like a data mining project. The second one is something we're doing more in the social media, kind of computational social science area. And the third one is a collaboration I've done in industry to show that these are not just pure just pure sort of for academic pursuit, but have real world impact that's quite valuable to consider these tails as well. Okay. So given that, let's hop in. Also, I'm occasionally watching the chat. So if you have any questions or comments, throw them in the chat, and I will try to respond. And so from earlier, I'll say good morning to Naomi. I see you posted in the chat. So I'll keep an eye on the chat as well. Okay, yeah. So let's get into that first project. So this is some work that will be published at Wisdom in the next month or so. This is a web search and data mining conference. And this is work that was primarily led by Jin Hao. Jin Hao was a master's student in my group, and now he's pursuing his PhD at George Mason with Zoe. And Zoe is a former PhD student from my group who's now an assistant professor at George Mason. So this is in the context of recommendations. So recommendations, if you think about like when you go on YouTube, what are the videos they recommend to you? Or if you go on to a job hunting site, what are the jobs that are recommended to you? So what we're looking at here is algorithmic bias or model bias. And so you can think about this. This is not bias in the data itself, right? We know if the data that is input to one of our AI or ML models has bias, that data bias can then show up downstream. So what we're looking at here is no. It's where the model itself can then exacerbate or amplify any imbalances in the data. And so what I'm showing you here is an example of the training data has some skew in a distribution. You can imagine a model, if not carefully designed, might actually skew, additionally amplify or skew that, that distribution even more. Okay, so we call model bias. And there's a lot of researchers thinking about how do you identify this kind of bias? How can we mitigate this bias, fight this bias, and so on and so forth. So what I want to do is just show you in the context of recommendation, different kinds of biases that do pop up. And I'll use the example here of like a movie recommender. But again, you could apply this quite broadly to any other kinds of settings. So it could be, what are the who are you encountering in your social media feeds, right? Those are all algorithmically mediated. So it could be on TikTok or X or Reddit or Facebook or Instagram and so on and so forth. But what I'll show you here is just some biases that show up in this movie space. And I hopefully that'll kind of motivate what we're doing. So the first one here is you can imagine we have different kinds of users who have different sort of degrees of mainstreamness. And so what I mean here is like the sort of blue people in the middle, they like kind of big blockbuster. They have mainstream taste, whereas these other users have maybe more niche taste. And so this is over some real data set. And you can look at like an off-the-shelf recommender, off-the-shelf machine learning model, and you can look at like how well does the model perform. And again, this is a measure of goodness here. And what you see here is those mainstream users are getting a much better result than our niche users here. So the niche users have poor recommendation service, right? This is through no fault of their own. It's just the way the model is designed. It tends to exacerbate and feed into users who are more mainstream. So there's a related kind of bias called user activeness. Now, this doesn't have anything to do with the particular taste you may have. It's just about how active you are on the system. So again, if you can imagine, if you're constantly upvoting or downvoting or engaging with the system, they have much more data with which to model you. And so here you see, again, these blue users have a big watch history, right? They watch lots of things. This user has nothing, and maybe this user has only one thing. And so it's the same deal. If you kind of look at this measure of goodness, you'll see that the active users get much better recommendations, much better model outputs than do these inactive users, okay? And you can see this not just on the user side, but also on the item side. So now forgetting the users, but if you consider just, experimental films, classic silent films versus items that are more mainstream. So in this case, big sci-fi action films and comedy films. And you see the same thing if we go look at, if you go look at how those movies are recommended, again, this is some measure of goodness, which I'm not going to define formally right now, but it's the same deal, right? These mainstream items get great reception, whereas these other items are poorly recommended. They don't get very much exposure. And you see the same thing in terms of item popularity. Again, you have some items that have lots and lots of watch history. It's sort of analogous to the user activity level. And you see the same thing here, which is, again, those items have wide reach and the unpopular ones don't have very much reach at all, okay? So I just want to show you this. We have lots of different kinds of these biases that can show up. And if you look at lots of traditional work, it's mainly focused on identifying each one of these biases and then crafting a solution that targets it. So for example, in this item popularity bias example, let's build a model where we can maybe reduce the effect of the item popularity and maybe increase the quality of those less popular items. But the issue is all of these different biases, it turns out they're all connected. And so kind of the argument of this work is that when we design these systems, we don't want to focus on isolated problems, but we need to think more holistically. And so I'll show you here, just again, this is through a data-driven study. What you're looking at here is, this is, for example, user activeness versus mainstreamness. And you see that there's a relationship. And the same thing with items. More mainstream items tend to be more popular. Again, you see this relationship here. And even across users and items, so like people in the movies, right? You see that the more mainstream the users are, you see that the items are more popular, right? So if you like mainstream things, you tend to interact with more popular things. So again, you see this relationship. And so again, our takeaway here is that all these biases are somehow related. And so if we build systems, we want to attack them kind of holistically. Okay. Now, if you believe that, my next argument is that I'm showing you all of this specifically in the context of some movie recommendation context, right? And movies and users and popularity and activeness. But what we're going to propose is a method that is generalizable to any kind of these sort of AI or ML driven systems that have these interconnected biases. And so what we're going to do is we're going to propose a method called CF Boost. And again, if you're kind of conversant with kind of the data mining machine learning literature, this is inspired by the classic Ada Boost, which is basically a boosting based framework. And again, it's designed to cover lots of different biases beyond what we show here. And so if you go read the paper, there's strong empirical performance. I'll give you some hints of that today, but there's also some nice theoretical analysis that Jinhao and Zouei led, which gives you some sort of nice properties of this method. Okay, and so it wouldn't be, I was going to say, it wouldn't be a CS lecture if I didn't, or a talk if I didn't show you an algorithm. So there's an algorithm, but let me come back to that in just a second and give you the intuition. So the big idea, if you're familiar with boosting, is you want to train a series of submodels. So we're not just going to train one monolithic model. We're going to have a bunch of models, a theta model, a theta 2 model, a theta 3 model. So we'll have T different submodels. And the hope is that each submodel can somehow address specific users and items. And so if you go back to my original motivation of kind of like this skewed distribution of different kinds of user groups, a single monolithic model may have a hard time modeling all of those different users and items, right? But instead, if we could have a method where you could have different parts, different submodels are optimized for different kinds of users and items, maybe we can build sort of an overall better model that reduces the bias, okay? And so the main idea here is the current model, we tried to basically reduce the training loss for the user item pairs that we've not done a good job so far. So it's going to be an iterative thing. We build one model, and then we check that model and we see, who are we not doing a good job for? Let's focus our attention there and build a new model. And then we'll iteratively keep looking back and say, who are we not doing a good job of modeling? And so at each step, we try to build a kind of a better model for each of those specific users and items. And then after we do this for T iterations, we can then ensemble all of those and get our final prediction. So again, here is just sort of the algorithm here, sort of in algorithm form, describing the words I did. But let me show you kind of visually what I mean. So what I'm showing you here is T models. So as you go down here's the first model, the second model, and then we have T submodels, okay? And what we're saying is the very first model we train, this is, imagine sort of the darker colors here are the better we're modeling those particular users and items. And so some of them we don't do a very good job, right? So you can see this gray here. We're saying we don't know much about them. This model is not very good at modeling them, okay? And so then we're going to do is we're going to build lots of models, right? So we're going to have with T different models. And then if you sort of jump to kind of the conclusion of all of this, when we ensemble all of the outputs, we're going to say, this is basically the guess from each of our models, and we're going to weight it by some alpha. And so we're going to aggregate all those submodels to make our final guess, right? Our final prediction. And so just to give you more sort of that intuition of what that alpha is, right? So that alpha we define as a sort of log of this 1/, that's the loss for that particular user item pair. And so the idea basically is that if we can effectively model a user item pair, that means we have a low loss. That means we'll get a high alpha. So then when we do the aggregation, we're going to say, we really did a good job, so we should really rely on that model's prediction very well, okay? But if we did a poor job, we should not rely on that prediction as much. Okay. So that's kind of the output of the model. But now if you rewind, you say, wait, but how did you actually like incrementally build the models, right? I'm just showing you sort of the end result here. We have the models, we aggregate their outputs. And my argument is this should work better than like a monolithic model. So if you actually rewind and you think about like really what's happening in this boosting iterations is really what happens is we build our first model, okay? And then we're going to have some weight, and we're going to then go build our next model. And so each model is dependent on the models that we've already built, okay? And so what we want to do is we want to then, as we go through these boosting iterations, we want to basically design the sample weights so that each time the model is sort of progressively getting smarter, okay? And so in that case, what we're going to do is we're going to have this weight. This is sort of this weighting factor. Notice here, this is on the t+1 weight is a function of the t. So we're kind of looking at the previous weights to then update the current weights. And we'll do here, there's our alpha again, and there's our loss. And so if you actually kind of play with this like on kind of real numbers, what you'll discover is that it basically ends up assigning higher weights to those underserved samples. So what'll happen here, like once we're here, we'll figure out which samples do we not do a good job on. So then we'll do a better weight on them the next round. We'll focus the model in terms of training on those samples that we did not do a good job on. Okay. For the other details, I'll sort of refer you to the paper, but right now my goal is just to kind of communicate kind of the high level intuition as to what we're doing here. And so if you're familiar with AdaBoost, this is quite similar. So let me just jump into some experiments and just sort of highlight what happens when you apply this, okay? And again, this is over some recommendation data set. We have some goodness metric. And again, I'm showing you those same different, this case is user mainstream from like low to high. So this kind of corresponds to those figures I was showing you before that look like this, right? So we had like different kinds of groups. And so what you're looking at here is, imagine these are, I'm not going to go into all the details of all these, but these are lots of baselines. Some of them are quite naive, like a traditional matrix factorization, but others of them are much more recent and are sort of these sophisticated, like we train multiple models and we combine them in smart ways. And so what I'm just trying to show you here, I'm trying to show you here is that we have kind of two different versions of the CF boost. And what I want you to notice is for this user mainstreamness, we tend to be doing a pretty good job, right? If you look at the improvements we're seeing, okay? Notice as we get to the top, sometimes we go worse or sometimes we have no improvement, okay? But what's nice is it's not just user mainstreamness we're targeting, but also let's go user activeness. Remember, this is just a single CF boost. We're not building special models for each one of these. But you see the same thing here, which is even though we didn't build this custom to target activeness level, again, you see nice improvements across the board. Again, maybe not at the top end, and I'm going to address that in just a second. So that was user activeness. Here's item mainstreamness, same deal. If you walk across, you'll see these nice improvements. And the last one was our item popularity. And again, same kind of story, which is we see these nice results. And notice on this one, though, you see a big drop on the top end. And so what's happening here is if you go back to the overall distribution, let's say it's something like this, basically what we're doing is we're saying we can really focus on these tails and improve them. But occasionally what will happen is we end up taking away some from the very top end, okay? And so that's a design choice we've made because again, we're focusing on those tails. And so our kind of our argument would be, overall, we can deliver nice performance. We're going to kind of equalize the results. But it might be that you can imagine a world in which it's very important that number not go down, right? And so in those cases, you can just ensemble this approach with the traditional approach, right? So you can still maintain your high quality on your top model, but use the other for the longer tail of the distribution. Okay. So the big takeaways from all of this, the sort of first piece of work, is basically like an AdaBoost inspired method. Again, I focused here on a particular recommendation task, but our argument is it could apply to many other kinds of biases And we're interested in taking the framework and trying it on different other kinds of applications beyond what we show here. And if you want to see, there's a very nice theoretical analysis that I refer you to the paper if you want to take a look at. I think it's quite interesting. Okay. All right, cool. So that was kind of my big kind of data mining style work. So now let's for those of you, you say this is not interesting to me. Okay, now put on your kind of computational social science hat, and we're going to take a big like left turn right now and look at kind of a different kind of problem space and a different kind of approach. Okay, but still kind of grounded in this idea of kind of neglected tales and kind of ethical AI. So this next project is going to appear at ICWSM this summer. It was led by my students, primarily by Maria, but also collaborated with Shangjua and Haoran. And the context here is gendered discourse in podcast and LLMs. Okay. And so think about this. So spoken content, right? We're moving to very much a spoken content world. We all talk to our phones already, but we have spoken content like through audiobooks. Many of you may listen to podcast. If you think about just the audio track on YouTube, right? We have lots and lots of spoken content, but also meeting transcripts and so on and so forth. So we're moving away from a world where our models are trained on and we as users consume written text. We're moving to a spoken world, and we're already there, to be honest. And so we know this stuff is out there already. Furthermore, the spoken content is not just ubiquitous, right? But we also know it's an important source for these big LLMs that are being trained. So if you have some audio source, some spoken word content, there's many existing APIs, Whisper from OpenAI, there's Google has ASR, and you can basically generate transcripts from your audio source. So you can turn your audio into text, and then you can feed that directly into the training of these models. Now I say that, but there are also, we also know that there are models being developed that go directly from, audio to let's call it a foundation model directly, bypassing this transcription. But the idea is we know that this kind of spoken content is definitely an important source for these LLMs. And so at the same time, we're coming at this from the perspective of this idea of what's called masculine defaults. So masculine defaults are basically a cultural bias that values or rewards characteristics or behaviors that are associated with men. And so typically you define a masculine default in a particular cultural context. So if you change the cultural context, the same default may not apply, okay? What I'm showing you here is researchers have noted that in the cultural context of the US, the prevalence of men in computer science is a masculine default. Part of that is because in the definition, because there is a reward to it, there's economic reward, and there's larger social acceptance. And so researchers have documented that women feel a lower sense of belonging and anticipate less success, okay? Even though, understanding algorithms and all these kinds of things have nothing to do with gender, right? And so again, but if you took this same, computer science and you translated it to a different country, maybe the default doesn't hold, okay? And you can imagine in your mind other kinds of defaults, okay? And so why do I bring this up in the context of podcast? So here's a headline from the last year talking about bro podcasters. And so the idea is on these podcasts, you have many, many podcasts that have kind of these quote unquote bros. And so what we were curious in this work is trying to understand who's talking about what on these podcasts. Are there masculine defaults? Does like gender matter? And then does that have any impact on these LLMs that are downstream of these podcasts? Okay, or we're using podcast here as a popular example of spoken content. Okay, so specifically, kind of hang with me here. I got to walk you through a few more steps to get there. So specifically, what we're going to look at is what we call patterns of discourse. And so what we mean there is that patterns of discourse would be things like fillers, what's called discourse markers. I mean, or false starts. That's where I start a sentence and then it was anyways, yesterday, like I changed the direction of my sentence. And so notice what I'm looking at here. This is not the topic. So we will look at the topics of what men and women talk about, but we're more interested in looking at these patterns of discourse. And so there's lots of previous work. Again, I refer you to the paper for the specific citations, but there's previous work that says, men and women use different kinds of discourse words. They use them differently. So for example, men may use more filled pauses and repeats, okay? Or there may be the more use of fillers or discourse markers if you're trying to hold the floor, okay? And so the idea is like these words that seem not that important to us, ooh, ah, well, I mean, we're curious to see in a large scale study of spoken content if they actually do reveal any interesting patterns. Okay. So if you're still with me so far, this whole study, just to kind of get to what the study is all about, is we're looking at these discourse-based masculine defaults. So we want to look at these words, ooh, ah, and basically what we propose is a framework that allows us to analyze spoken content, find gender discourse words, and understand the spoken content from this perspective, purely in the podcast or spoken content domain. And then we take those findings and we move them over to the LLM world, because again, our hypothesis is LLM may have ingested some of these gendered framings. And so our hypothesis is we may see that in the LLM side of things as well. Okay. Okay, cool. And I'm still looking at the chat if you have any questions. I may start asking myself questions here in a second. So they, well, okay, that's interesting. Is that the right way to approach this problem? I don't know. Let's think about it. Okay, here's a great question. Can we truly achieve this mathematical algorithmic model level? There's no free lunch theorem has proven that no single model can universally dominate all possible problem distributions. Yeah. This is a really great question. And I'll take a stab at it right now, and then we can open it up maybe later on for a discussion, which I think would be a great opportunity. Yeah, so, what I would say is like in practice, a lot of my stuff is very like empirical. And so in practice, when we think about building these different models, in practice, there's typically not the single model to rule them all. And so typically we're building these ensembles and we're constantly monitoring the output of them. And so, yeah, I may have to spend more to develop and maintain multiple models, but in practice, that's what I'm typically going to do. Now, what's interesting, I raise that because if you talk to lots of people right now, this is sort of ancillary to what you're posting there, which is this move towards this AI or potential AGI, right? Some artificial general intelligence. What's interesting is there is a lot of push towards a single model to do everything. So why do I need to develop a custom model for summarization and for the mathematical analysis and for finding new scientific theorems and for doing drug discovery? And so, I mean, a lot of people are talking about we don't need that anymore. We only need the one model to rule them all. I'll leave that for a discussion we can come back to at the end. But thank you so much for that question. Okay, so back to our kind of discourse and gendered discourse. So let me show you what we actually built. And so basically what we take in on the left-hand side is podcast audio. Podcast audio. And I think here it's on the order of like maybe 20,000 different podcasts. So we have hours and hours and hours of audio. We got this from this Spotify podcast data set. Okay. So we take all of that audio and we run it through a gender segmenter. And this is off the shelf. And it basically tells us in this podcast how many like quote unquote female voices it hears versus male voices. So this is not a perfect tool, and I leave that as a sort of a future work, but we're using this off-the-shelf tool just to get us kind of a rough cut of the gender differences in this particular podcast. Okay, so we have that to the side. Then we run this through ASR system, we get the transcripts, and then we run that through different parsers. So we do some fun stuff where we look at parts of speech here. Also run it through topic modelers. So we have an LDA model here. We also have something called BERT topic, which generates different topics based on the different podcast. And we also look at other factors like the transcript length and the duration and so forth. And then basically we do a Bonferroni connection for the Pearson correlation. And then we can go look for significant correlations between these different factors. Okay, so things like, longer podcasts tend to be more male or more female, or certain topics, so on and so forth. Okay, and so we have this framework, and we can generate lots and lots of these features. Okay, and we have a project website. If you find this interesting, you can take a look at it. And we'd be happy to share code and results out of this. So given this big framework, right? So we take in the audio, we look at the gender segmentation, we do this topic modeling. And so we have lots of kind of results in the paper. But the first thing is, people haven't really looked at this kind of scale of spoken content to understand the patterns of how people are really talking. And so the first thing I'll show you here is, very naturally in these podcasts, you can imagine men and women are engaging in different topics, right? And so what I'm showing you here are those correlations. So here what we're looking for are ones where we have a strong positive and a strong negative. It's not always the case that happens. There's many topics that are sort of gender, quote unquote, neutral. But what you see here is, pregnancy topic, because we're looking at who's actually speaking, we find, women are speaking about this topic more than men. Whereas on the flip side, right, you see this is a sports topic, which has more men talking than women. Okay. And so this is very kind of natural. You can imagine it. You also see some different topics, but you also, what I want you to notice here is at the bottom, these words, these are the discourse words. These are not topic specific, but it's just like how people talk. And so, hey, and I was going, hey, it's cold outside. So going is not like communicating something special about the content. It's just sort of a way of speaking. Oh, let me rewind, right? This is also, all these findings, this is all in the context of, English and primarily US-based speakers. And you can look at the age distribution and so forth. So again, this is a framework. You would find different results if you applied it to different spoken content from different cultural context. But what I want you to get from this is if you look at those two topics down there, those are our discourse words. And what we see is, in this top one, this is men. Men are saying going, no, think, got, get, really. Women are saying like, no, really, going, people, want. Okay, so distributionally, they're quite different. And if you look again at the correlations here, they're quite different. Okay. And so again, what we're saying here is like, okay, over this collection of podcasts, men and women are talking about different topics, but they're also talking in different ways. Okay. And so part of that, if you go into there, even if this is now sort of the next part, if you go into a particular podcast topic like business, what you will discover is that both men and women are speaking according to male frames of speech, male discourse. Okay, so when we talk about masculine defaults, that's what we mean. If you're going to talk about business, at least on these podcasts, it has a male, is biased towards male and male framings. So you'll see that the female voices will speak more using this, like literal female voice, using more kind of these male-centered words. And vice versa. If you're looking at a quote unquote more female topic, men in that space will be adopting words and discourse words that are more appropriate for that space. So when we talk about kind of these defaults, it's like how people engage in different topics. They actually speak about them fundamentally differently. Now, and sorry, and I refer you to the paper. You find lots of other kinds of these relationships, sort of observational and correlational relationships. But the next step in this work was we wanted to say, now, does this sort of gendered framing get into those LLMs? And so we were inspired by, you may be familiar with this thing called WEAT. This is the Word Embedding Association Test. It was proposed back in 2017. And basically, you can look at different word embeddings. So like you can see here, this is glove, here's word tvec and others. And basically, you define a number of target concepts and you define a number of attributes. So for example, if you're doing like, again, male versus female and career versus family, you can go look in the embedding space and find that these embeddings have learned some bias towards one or the other. So the idea is sort of these human biases that we would, hope were not sort of embedded in these models actually are, okay? So we took inspiration from this, and what we have is what we call a discourse. I like that, a discourse wheat or D-wheat. And what we're doing here is basically we have the same kind of attribute words. So you'll notice here, these are like female attribute words. These are male attribute words. But now we can go and look at those discourse words, like words that you think are not that significant. Going, no, think. And we can try to see how they are placed in this space. Like, do they reveal some bias? So what I'm showing you here on this side here, imagine you have a sentence, and I was going, hey, it's cold outside. And so we know going is here, but what if I replaced it with like from the, which is more of a female associated discourse word. So it doesn't really change the meaning of the sentence, but does it move it around in this LLM embedding space? Okay. And so we want to see what happens if we swap them around. And so we do this masculine to feminine, we do this feminine to masculine word replacement. And so if you walk through all of this, you can basically see like we have this parameter, which is like how many of these replacements do we do? And basically what you're just seeing here is like this is some male sentence in the embedding space. Okay, it should be, we would expect to see this. Male for men and women, it's like totally in between. It's just a sentence. I was going, hey, it's cold outside. Okay, but it was spoken by a man. In this case, if we increase the number of like female discourse words like going or excuse me, like, you'll notice that it skews it up towards, it becomes, the model thinks it's a female sentence versus a male sentence, and vice versa. And so we're saying here, there's no reason that it should change. Our hypothesis would be, it should be like this. It shouldn't change. These words don't really have much meaning. It's just, hey, like. And so kind of our argument here is these LLMs are, even though we don't think about lots of these words communicating some kind of implicit gender, they are. And in fact, it's all throughout these models, and you can't really avoid it. And we have, again, more experiments in the papers to look at this. So this is kind of work quite different from the first piece of work I showed you. But I just wanted you to take a look at this. I'm very excited by it, and we're still working on this topic very much. But it's just trying to figure out that, like, yeah, these discourse words, again, or like, that we often sort of ignore, particularly like in written text, right? But if you think about how we speak, it actually conveys lots of implicit gender information. People have known this for years, but we've actually just studied it at a big scale on these podcasts. We have this D-Wheat. Go take a look at that. It joins, there's a long list of other kinds of methods in this space, but we think it's kind of a new and kind of interesting way to look at bias in LLMs that's derived from kind of the spoken content. And there's also some evidence in the paper I'll refer you to that men actually have a more robust embedding in these LLMs than women. And our hypothesis or a hunch is that could affect kind of these downstream applications. So if you're using an LLM, it may be baked in that it has some of these biases in it. Yeah, so let me wrap up that. And then I've got a question from Sopam who says, could it mean that women or men in general use certain words which may mean the same thing, but for some reason, a particular synonym is used by a particular gender in the real world? Yeah. So I think that's a really great point. So yeah, if you basically, exactly right. So if you aggregate this and you had, imagine you're not going to see this exact sentence, but the sentence could be something like, hey, I'm going outside. And if imagine we sampled 10,000 versions of that sentence, what we're saying is we're going to see a difference between men and women. Hey, I'm like going outside versus, hey, I'm, I forget what the word is. Hey, I'm going outside. And there would be a difference. And so our argument is they're fundamentally using these words differently, and that's them being captured. Now, to your point, it could mean that that's actually an interesting difference that the LLM or whatever downstream application may want to be aware of. People speak differently, and we need to know that because we can improve, the quality of our service or the model that we provide to those different users. So we're not arguing that's not necessarily a bad thing, but we just think it's a thing that needs to be recognized. And in some cases, we do think it could be a bad thing. And so the argument is like we need tools just to know it exists. And because that's basically what this effort is. Let's build tools to analyze and understand. And then sort of those next steps, this comes back to my need for practitioners, philosophers, ethicists. What's the next step? Yeah, great point. Okay. So everyone has been very patient. Thank you for staying with me. And so I'll do this last bit. We'll go a little bit faster so we can finish up a little bit early here. But the last bit is I want to show you that all the work I've been talking about neglected tails or like these distributional effects, again, it has very concrete, like bottom line impact. You can make money if you care about this, okay? And so this is work we published last year. This is with my colleagues at Google DeepMind using LLMs in this cold start item recommendation. And so if you think about this is, again, very practical, but like here is a DeepSeek. Everyone is very excited by DeepSeek right now. And it's a little hard to see, but this video came out and has 1.7 million views. This video came out at the time I took the screenshot, it has 0 views, okay? And if you're familiar at all with YouTube or any of these other online platforms, this is a very like natural phenomenon. I alluded to it at the very beginning of the talk about like different item popularities, but this is a very concrete example. So this guy, the top guy's video has millions of views in a couple of days. The bottom one at the time had no views. And so if you look at the distribution of views on something like YouTube, so you can imagine, I mean, I'm just sort of something like this, right? A few videos have lots of views. Almost everything has 0 or few views, okay? And so if you are YouTube or you are, whichever major platform, that can be a problem because basically you want your content creators to be engaged and rewarded by the system. And yet if they're crowded out by these popular videos or popular content creators, they can't build an audience. They can't build the network effects. They can't build your platform, okay? And so as a result, if you're at one of these big companies or you manage one of these big platforms, there's big interest on taking a look at this long, or what we called earlier, our neglected tails, and doing our best because there's someone who wants to watch this video. There's someone out there who wants to see it. We want to get them connected to that video. And if we do a poor job, we may not be able to do it, and then problems ensue, okay? So what this work is all about, it's a very simple idea, but basically it says, we're just going to say, if I'm at YouTube, I have all my clicks from my users. That's all my original training data. I build a model, go. Now what we're going to do is we're going to say, no, let's use LLM to basically augment and create kind of synthetic users. Okay. And so if those LLMs can generate synthetic or augmented training signals, they can basically fill in the gap for all those those videos that no one's ever watched. Okay. And what's neat about this, I have this big line here, is this is all like doesn't affect your model pipeline. And so if you know how these big companies work, you have all these engineers, they build this big complex engineering pipeline to serve their recommendations to turn all these insights into like the practical like interface that you engage with. And it's very difficult to modify. And so what we're arguing here is you don't need to touch it at all, but we can actually update your training data using LLMs, and then everything beyond there can just ingest what we've already given you. Okay. And so this is, the benefits. The idea is this can be super efficient. It's all during your training phase. There's no latency at inference time. And there's another question in the chat I'll come back to in just a minute. Thank you for that. The other thing here is that, the LLM is totally like compatible with any framework, and it's totally model agnostic. Again, I'm arguing everything lives just on the data side, and then you can just plug it into whatever pipeline you already have. Okay. So you may be asking yourself, but how do you actually like get an augmented training signal? And so this is a very simple idea, but what we do here is basically, I'll focus you down here on the prompt we give it. We basically say, here is a user, and this is their history. So you can imagine if you've been on YouTube before, these are the videos you've watched before. Okay, if you're on Amazon, these are the items you've bought before. And then we basically say, here is a new video or something you've never seen before. That's a new one. And that's a new one. In this case, this is some items from Amazon. And we basically ask the LLM, we say, hey, the user purchased that history. Which of these two new items would they prefer, A or B? So it's a pairwise comparison. And in this case, this user has purchased some mask, a serum, some haircut stuff. And we ask it, would this person like a hair conditioner or some mascara? Okay. And so now we have a pairwise preference. And the point is we don't really know because the user hasn't seen A or B before, but we're sort of simulating what the user would like. And again, the argument is not that the LLM is always perfect, but that more often than not, it maybe can do a better job than nothing. Okay. And so we take those training signals and we basically just plug them in. We add them to our regular training signals. In the interest of time, I'll skip over this. But basically what I want you to see here is this cold start case. This is where we have a cold start item. That means an item that no one has ever, it's a video no one's ever watched. It's an item no one's ever bought. These are these are just two different models. They're not ours. They're someone else's. And we basically say it's like, what if we do just the vanilla model? I'll just highlight here. Versus what if we augment? In other words, what if we use our synthetic signals from our LLM? And the idea is if you look across the numbers are low, but they get much larger, right? So just by augmenting for these different topics, you can get a big improvement. In other words, the LLM somehow, this is a hard thing for me to grasp, somehow can impart some wisdom that can synthesize what the user would have picked. Not always right, but it does improve the model significantly. And again, I'll just to highlight. So for example, like if you look at that one, we go from 0.74 to 11, it's a big, big improvement. Okay. And just like the stuff I talked about at the beginning, well, maybe if we use this model, maybe it'll hurt the items that we know so much about. We call those warm start items. Those are warm start items that we know a lot about. Lots of users have seen them already. And so what you want to see here is, again, like, look, there's a big improvement there. And then for warm start, you'll notice there's very slight negative. Okay. Or if you look at this one, we have a big improvement here and a very slight negative from the warm start. So again, the argument here is we can really improve those items that have not been interacted with, and we can hopefully raise them up. And again, why does YouTube or why does Google care about this? Because this drives the bottom line, right? So really taking care of those distributional effects is quite important. Okay. And then some other result here. But the main takeaway from this work is basically LLMs are super helpful. They can synthesize lots of additional features. They can basically synthesize users. And it's also a great opportunity to combine the benefits of LLM plus existing pipeline. So again, if you have, this is just sort of, you're probably all familiar with this, but if you already have some project you're working on, LLMs are very helpful to give you additional signal, even if you're not replacing the whole model with the LLM. So just to wrap up all of this, again, just to emphasize, I think top-line metrics are important, but it is critical to think about distributional effects. That's kind of what I want you to take away from all of this. Very obvious to some of you, but for me is a big learning and across many, many different tasks. And I hope you are convinced that many like state-of-the-art systems are not well designed for these. And so I'm thinking us as sort of computer science scientists, we need to think about these edge cases and long tails. And so as I answer a question here, my last slide is just a repeat of what I showed you earlier. is, again, I'm not a philosopher. And like I don't know the right way to do some of these things. And so I hope we can have more collaboration. Okay. Thank you all for your time. I appreciate it.
Yeah, so thanks, Dr. Caverlee, for his wonderful talk. Very interesting empirical findings. Yeah, so we have several questions posted in the chat, and
Kill my share. Yes, I see one from Kai
Yeah.
says, is it possible to modify the boosting to address social bias? Yeah, this is a really great question. And so in that context, right, it all comes back to a lot of this is domain and data dependent. And so we were looking at like an e-commerce domain where social bias is not a big topic, right? It was this users and items and so forth. But I think your point about like in a different domain, where, for example, gender or race or age, country of origin, if those are important features or factors, then yeah, I think there are ways to adapt this to better model if those are significant factors in the model. Yeah, I think it's a really, really good point.
Yeah, so please feel free to ask questions. You can post your questions on the chat, or you can enable your audio and you can directly ask your question.
I talked a lot too.
Yeah, I have a quick question. So,
Yeah.
so what could be the situation if we do not know the source of bias? So, for example, we do not know its gender or race.
Yeah, this is a great question. So what if you don't know the source of the bias? Yeah.
Yeah.
So there's lots of work. Yeah, a lot of work is basically in terms of probing, but it comes from, this is a really great point, which is I, as a domain expert, need to come with my own mental model. I think there may be age-related bias. Let me go find it. I think there may be country of origin bias. Let me go find it. Versus these more kind of insidious biases that are harder to identify and harder to find. So that's a great question. I've seen some work I can share offline. People have tried to, it comes back to a little bit to AI explainability or interpretability, which is basically saying, you give me a model, you give me lots of model outputs, I can find strange phenomenon and I can try to attribute it to some features, but I don't know what it means. I don't know why it's there. And I think that really motivates the need for these collaborations, HCI, interpretability, ML to understand. Yeah.
Thank you. Thank you. It makes a lot of sense. Yeah.
Great question. Thank you. And thank you everybody for taking the time. I really appreciate it. You have my name. Feel free to email me offline, anything. I'm happy to share. But other than that, I really appreciate all the questions and all of your attention. Thank you.
Yeah. Thank you. Thank you for your time. Yeah. Thank you, everyone, and have a good weekend. Bye-bye.